I'm going to go ahead and get started. My name's Laura Sinclair. Welcome to the first Erector webinar of our three-part series. Today I'm going to be covering the bid phase for Erectors. If you have any questions, feel free to type them in the chat area at any time and I'll answer a few at the end. So 3D models have been used for years by erectors, engineers, detailers, and fabricators. The fabricator model is going to be the source for all the fabrication and erection information. And then the fabricator model is also going to be the most accurate and updated throughout the project. All the CNC files are going to come from the model, so it's going to be the closest thing to what you see out in the field. So today I'm going to be covering how to utilize this model to benefit the erector. Today I'm going to be covering the bid phase. So before being awarded the project, we'll be walking through how to get a quick and accurate bid for the erection out of the prefabrication model first. And then we're going to compare the costs after receiving the actual fabrication model. Next Wednesday, I'm going to be covering the pre-planning phase, so that will be on November 13th at 10:30 a.m. Central Standard Time. And then we're going to be covering once you've been awarded the job, then you can start planning out the erection sequences, utilizing the crane tools, putting a crane placement on the erection drawing, and even sending this model out to Fortisea. So that's going to be SDS2's load planning solution, and I'll cover that briefly too. And then we'll close it out with the on-site phase on November 20th, again at 10:30 in the morning Central Standard Time. So once the steel starts to arrive to the site, we can then start keeping track of how the information is sending back to the fabrication model. So it's always going to be up to date. I can quickly then run reports, and then this will also be a great visual tool for everyone to see out in the field. So the drawings more than likely will be out of date once the erector starts to bid. So reading from the 3D fabrication model instead of the drawings, we're going to be more accurate for the bid. You can not only use the 3D model as a visual, but then it's going to also be the most accurate. I can then, since the fabrication model is going to be the closest to what's going to be out in the field, then I can start running reports to determine what type of cranes are needed, where they need to go, and then send this information out to BidWizard for an estimate. In today's webinar, I'm going to concentrate on one erector flow. I understand that there's going to be a lot of erector flows out there, but I'm just going to focus on this one for today. I'm going to take a prefabrication model that's been created in Revit and then send it out to BidWizard for a bid on the prefabrication model and then also on the fabrication model once it's been awarded. Parallel to that, while I have the prefabrication model inside of the job, I can start to determine what crane I'll use and have a good idea where it needs to be located. So maybe I want to know what the heaviest member is or the heaviest piece of steel in my job. I can find that and then maybe place my crane closest to that. So I'll have my prefabrication model to compare with my actual fabrication model in BidWizard to see how far off I was in the beginning, and then I can go from there. Alright, so now I'm going to go ahead and jump into Revit. This model was graciously provided to us by Ascension Group Architects and Layton Construction. So we've created a plugin that installs inside of Revit called SDS2 Connect. You can purchase the connection design, but in this case I'm just going to use the free plugin that exports an XML file to SDS2. This is going to export beams, columns, bracing, and joists. I can export an SDNF file or an IFC file as well, but the XML file provided will be the most information for the steel inside of SDS2. Now for time permitting purposes, I'm going to say that a revision came back later on in the project and I actually needed to move that beam down 2 feet. I can simply export out another XML file and then it's going to update inside of SDS2. Don't worry, I'm going to show this a little bit later. Now that I have that, I also want to export out maybe a DWG file to see where I can do my column laydown points. I can then snap to these points or use them as a reference inside of SDS2. Now I just want to see maybe all of the concrete that could obstruct inside of SDS2, so all I want is the concrete in here, so I'll just simply hide this. And then I'll export out the IFC file to see if there's going to be any concrete that's going to obstruct my crane laydown points. I'm now going to head into my Erector station. The Erector Plus is what I'm going to be using. It's going to give me the full capability of modeling, and maybe even if I was going to do the design build, I can design my own connections. Like I stated before, I can import the XML file that will have all of the connections in it, but in this case, I'm just going to import my members. Working with the XML file, it's going to link my Revit families with the properties of SDS2 so I don't have to do that extra mapping. Once the steel is imported, then it will automatically read all of my setup information so I don't have to go one by one and make the adjustments. So utilizing the other file types from Revit, then I can import in that IFC file. It can be brought in just as a reference so I can turn it on, turn it off, just to see if there's any obstructions from my crane. I can also then import in the 2D drawing and I can overlay that, and then it can be a really good reference for when I want to maybe add in some columns or look where those columns actually need to be placed. Along with the IFC file, I can also turn this on and off to my liking. I can even go into my drawing editor and make modifications to this file, and it will update into the modeling. I'm going to concentrate on the lower part of this building. And let's say some time has gone by and there's already been a modification to the building. I don't have to delete all these members and re-add them with the new XML file. I can actually import in that XML file again, and what I personally like is it will take me right to where that is in the model and show me what's about to update instead of not knowing or trying to guess what has changed in my model. To determine where I want to place the cranes, I want to find out what the heaviest piece of steel is for this XML file. I know that in the model it will likely change from the finished fabricator's model, but then I can get a rough idea for the crane placement. So I just have to simply run a report and then I can find where that piece mark is or where that piece of steel is in my model. Once it takes me to where that is in my model, then I can save this for a later date that I'm going to actually use in my second or third webinar. Now that I have that, I'm ready to start placing my cranes. I can then hide my IFC file or my reference model and my DWG files, and then I can start placing my cranes. Now these cranes are just going to be a tool to assist you. It's not going to be to replace anyone. I can add in a tower, crawler, or a truck crane. Currently I'm going to use a crawler crane. I can add in a tower crane, a crawler with a fixed or a luffing jib, or a truck crane that can be an all-terrain, a rough terrain, with a lattice, and a telescopic boom with both fixed and luffing jibs. You can place your own configurations if they aren't in this list of the crane types that you want. Now I'm going to modify this configuration just a little bit. I'm going to maybe give this a 4,000 pound block, 300 pounds for the rigging, and maybe 15 feet for the remaining. Then into the whip, I'm going to do 300 for the headache ball, 300 for the sling, and then 15 feet for the remaining again. I'm going to go ahead and add in my first placement. I can have multiple placements for one crane, or I can even have multiple cranes on this job. Now as I start moving this around here, it's going to check for the feasibility of the lists on the fly. As the crane's being placed in the software, it's going to check for the strength and stability of the crane. It's going to also check for like the hoist capacity, the reach radius to the center of the mast, and the lift height of the set location. As I start to locate the crane, you'll see a dome, or in a plan view it'll look like a circle with rings around it. The rings are each going to represent 10 feet increments of where the crane can actually reach the steel. Once I have my crane in there, then I can start utilizing the different tools for the crane. One of the tools that I can run here is to show the liftable members that this crane can do at this placement. So you can see the dome there representing the radius. Now I can see the green will represent the liftable members at the set and pick points. The red is going to be where it fails, and then the orange, if it was orange, it'd be a critical lift. I don't have to keep this crane placement where it's at. I can either move that or I can also create a new one. In this case, I think I'm going to try to move it down on the project just a little bit to see if I can pick up some more steel, because what I'm trying to do is to minimize the amount of loads that I have to do on this project. Alright, so I can see here after running the liftable members again that I can definitely pick up more steel as I have it at this location. I mentioned before that you can have more than one placement, so I'll just quickly add in another one for this crane and maybe move it towards the outside of the building so that I can start to go around the exterior. I can run the show liftable members again just to see how many pieces of steel I can pick up with this crane placement. Now I see that I don't really pick up any more than the first crane placement, so I'd probably want to move that down. But for this purpose, I'll just leave it. Now that I have my most current XML file, I can export all this information out to BidWizard for an accurate bid for my prefabrication model. With BidWizard, you can utilize more than 300 of their built-in task formulas to help with the estimate that can include maybe labor, crane, welders, fuel, and even the equipment. So I'm going to type in a few of these fields. I want this to be called maybe my prefabrication model, and you can see a lot of the information in here that I can utilize. Now I'm just going to type in a few of the fields. Maybe I want this to be a 12-man crew, and I want my structural square foot to be 95,000. I'm going to come down to the tasks and maybe just import in the XLSX file for SDS2. So 10 tasks have been updated here, and as I scroll up I can start to see that the fields have started to be populated. So the actual cost based from the steel in my model would be about $58,000, but I could bid my bid in around $77,000 for a profit of $18,500, and that would take roughly 13 days. So now that I have my prefabrication model done, let's just say that time's gone by and we won the bid. So I'm going to receive my finished fabricator's model to compare my estimate. I can quickly copy in my crane from my other job so I don't have to set up all of that information again. Now opening up my model, I can already see the crane placements are there along with my crane. So now I want to see what the piece of steel is going to be the heaviest in my fabrication model to see if the cranes are in the correct placement. I can always move them just like before as well. It looks like the piece ended up being correct and they just ended up combining two columns as one. I just want to save this as the heaviest member again for later use in my second webinar. Now I want to see what my liftable members are for my fabrication model. So I'm going to go ahead and run the liftable members like we did for the prefabrication model. And I'll select the placement up above because we knew that that picked up the most members. I see that using that crane placement and running the tool, it's going to pick up about the same amount of steel, so I'm going to go ahead and keep that crane placement there. Currently in this export, we send out the beams, columns, and bracing to BidWizard. So I'll just go ahead and create another file just like before. This will be an XLSX file, so you can open this up in Excel and view it as well. I'm going to open up BidWizard again, go to my bid list so I can have a whole list of different bids here, but I'm going to create a new one calling this as my fabrication model. Again, I'm going to type this in for a 12-man crew with 95,000 for my structural square footage. And then the only other thing that I'm going to change in here is I'm going to import in that BidWizard file that I exported out of SDS2 and select SDS2 for my application type. So now that 14 tasks instead of 10 tasks have been updated. Compared to my prefabrication model, so this cost is going to be about $62,000 instead of $58,000. My bid would be about $82,000 from $77,000, and my profit will be $20,000 instead of $18,500. And now I see that it's going to take 14 days instead of 13 days. So that concludes today's first webinar about the bid phase. I was able to cover the power of using the fabrication and the prefabrication model and able to get quick and accurate bids out. I was able to utilize SDS2's crane placement tools to determine where I wanted my crane placements to be for the least amount of lifts. Make sure to tune in next week where I'm going to break down the erector sequences, utilize more tools for the crane layouts for the erection views, and also sending all of this information to Fortisee for load planning. I'm now going to give you a few moments to type in your questions if you have some, and I'll answer a few. If you have any more questions, please don't hesitate to contact our sales department to schedule a demo or contact your support rep to answer any technical questions.